Welcome back and welcome to section 5.4, the derivative of exponential functions. We're talking about exponential functions in this case. In this chapter, the section, we're going to be looking at the derivative of f of x equals e to the x, the exponential e. We've seen e several times now, so that's what we're going to work with today. So how do we find the derivative? The derivative of e to the x. Recall, and most of you did wonderful on this topic before, the definition of derivative. The derivative, d dx, the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h, isn't it? We remember that, of course we do. So if we're given f of x equals e to the x as our function, then the derivative is equal to the limit as h goes to 0 of f of x plus h. So we take that x out, we're going to plug in x plus h in its place, and we get e to the x plus h minus the function, which is e to the x all over h. To find the limit, we first try to plug in what we're going to. So we take that h goes to 0, so we're going to plug in a 0 where we see an h. So here we have e to the x minus e to the x. That gives us 0 over 0. That's our indeterminate form. So that tells us we have to do something with it. What did we do with it? Well, we can look at it graphically. We can try to factor. We can conjugate. So lots of different things that we did with this. In this case, I want to go ahead and factor an e to the x out of the numerator. I have e to the x plus h here, but remember when we multiply common bases, we add the exponents. So I can break this apart and say it's e to the x times e to the h. Because if I pull these back together, I have common base, so I would add their exponents. So e to the x times e to the h is equal to e to the x plus h. So I can pull out an e to the x. That's going to leave me with e to the h minus 1 over h. This e to the x, since there's no h variable in it, and it's being multiplied to all this, I can bring that e to the x out of that limit. So I'm looking at the limit, or e to the x times the limit, as h goes to 0 of e to the h minus 1 over h. Again, I'm going to plug in that h equals 0 and see what I get. Again, I get 1. E to the 0 is 1. Minus 1 gives me 0 over 0. That's, again, the indeterminate form. That, again, is a problem. So what do we do with that? Well, what we can do is go ahead and look at this now graphically or tabularly. So let's see if I can't get my calculator to focus in on there. So I'm going to go to my y equals. I've already typed in my function, my e to the h minus 1 over h. Instead of h's, though, my calculator recognizes the x variable. So to put this in your calculator, go to your y equals. You can do second, and then natural log down here. That gives you the e. Then you type in your x minus 1. Make sure that numerator is in parentheses, divided by x. And we can graph that. I'm going to make sure I'm on a standard window, number 6. So here comes the function. So notice there we have it, and it looks like we have a value there, so we can go ahead and hit trace. And at 0, notice we don't get a y value. But if we were to type in 0.000000001, which is very close to 0, notice what I get. I get y equals 1. If I plug in negative 0.0000000 as many as you want, 1, notice what happens there. I also get y equals 1. So from the left side and the right side, I'm getting closer and closer to 1. So, by definition, throw my calculator away. Don't need to do that. The definition, the limit as h goes to 0 of this big old thing here is 1. So I have e to the x times 1, which is e to the x. Isn't that bizarre? So the derivative of e to the x equals e to the x. Dun, 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 dun. Isn't that cool? So the derivative of any e to the x, any e to any single variable is e to that single variable. Now it does get a little more complicated as we make that exponent a non-single variable. So our rules, if f of x equals e to the x, then f prime is going to equal e to the x as well. What happens if we have f of x equals e to a function? So say maybe g of x here is x squared plus 1. Well, then to find f prime of x, I would take the derivative of that exponent times e to that exponent. So in this case, if my f of x was e to the x squared plus 1, then my first derivative would be derivative of that, which would be 2x e to that exponent. The thing you want to remember, the exponent of e never changes. The exponent of e never changes. Never, ever, 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 ever change the exponent of e when you find the derivative of it, please. So what is this going to look like? Well, if I give you f of x equals 4e to the x, my derivative, well, 4 is just a constant, so I take 4 times the derivative of e to the x. Derivative of e to the x, remember again, is e to the x. So the derivative of 4e to the x is 4e to the x. Can it get any simpler than that? I don't think so. Why do I have 4e to the x twice? Don't need that. Let's move on to the next one. 2e to the negative x plus x is our new function. Our derivative, again, we're going to take the derivative of 2e to the negative x. Derivative of the exponent is negative 1. So I get negative 2e to the negative x plus derivative of x, which is 1. I do not, and you know this, do not like those negative exponents. So we're going to go ahead and clean that up by making it a positive exponent. To make it positive, we take it to the denominator of our fraction. You may also be able to find a common denominator between these two. So our common denominator would be e to the x. Remember that 1 is over 1. So we get negative 2 plus e to the x. And that'd be a beautiful answer if you would get that to that point in time. And that's our first derivative. We can also do a little product rule and quotient rule. We'll do some basic ones today, nothing too miserable. And then tomorrow we'll get into a little more complicated problems with this. So our derivative here, we do have product rule, since we have x squared times e to the x, and we have x's in both of those terms. So product rule tells us 1 d2, derivative of e to the x is e to the x, plus e to the x times the derivative of x squared, which is 2x. From here, all we can do is clean it up. So we're looking for the GCF between these two terms. Normally, we'll always be able to take out an e to the exponent that we're working with, and also maybe some variables or some constants. So here we can take out an x, and then e to the x. So we're left with, if I take x squared e to the x and factor out an x e to the x, I'm left with x. And if I have e to the x times 2x and take out an x e to the x, I'm left with a 2. So that's going to be my nice, clean, simplified form that I would probably see on a multiple choice test or quiz. And finally, I wanted to do a simple, more simple quotient rule that we're going to have and see. So here, quotient rule tells us low, so their denominator, times the derivative of the numerator, d high, derivative of e to the x plus 2. Derivative of x plus 2, if you need to, you can come off to the side. G of x equals x plus 2. X plus 2. I could write a plus sign today. So I get g of x equals that. G prime of x is going to equal 1, isn't it? So derivative of e to the x plus 2, I take the derivative of the exponent, which is 1. E, and that exponent will never change. Minus my numerator, e to the x plus 2, times derivative of x, which is 1, over the denominator squared, which is x squared. Finally, again, we can go ahead and clean up by factoring out the GCF in the numerator. Again, we'll see that we can take out that e to the x plus 2, times, we have an x left over, minus a 1 left over from the second part. And that's over x squared. And that gives us our derivative. So just to recap real quick, the derivative of e to the x, the derivative of any e to a single variable is e to the x, or e to that single variable. If we have e to a function, so it's just not an x variable, then we got to take the derivative of that exponent, multiply it to the front, the coefficient, and then leave the exponent alone. The exponent of e will never change. The exponent of e will never change. I will not say that enough, because ultimately somebody will try to change the exponent of e, and I will tell you again and again and again, the exponent of e will never change. Good luck, enjoy. If you have questions, let me know.